Hey guys, so in this video we're going to learn about quadratic inequalities. So here I have the quadratic expression x squared minus 8x plus 7, and I want to find the values of x for which x squared minus 8x plus 7 is greater than 0. Now to understand this visually, we can see here that we have the graph for y is equal to x squared minus 8x plus 7, that's this parabola, and we want to know the values of x for which this curve lies above the x-axis. So the values of x for which y is greater than 0, that is x squared minus 8x plus 7 is greater than 0. So the values of x that we're really concerned with are the ones that represent the shaded regions here. So what we can do here is we can find the values of x for which x squared minus 8x plus 7 is equal to 0. Those are the values of the x-intercepts. And then we can determine the values of x for which this expression is greater than 0. So what we want to do here is first we want to factorize this quadratic expression. So in order to factorize, what we can do here is we can take the coefficient of the x squared term and the constant terms. The coefficient of the x squared term is 1 and we multiply it with the constant term, that's positive 7, and we get 7. Now since this product is positive, right, since the coefficient is positive and the constant term is positive, we want to know what factors of 7 add up to give us 8. And we know that 7 times 1, right, 7 times 1 are factors of 7, right, and if 7 and 1 are added together, we get 8. So we know that x squared minus 7x minus x plus 7 is greater than 0. What we can say is we can factor out x here, so we get x minus 7, and we factor out negative 1 here, and we get x minus 7 again, and that's greater than 0. So therefore x minus 1 times x minus 7 is greater than 0. So we factorize this quadratic expression here. Now we know that this entire expression is equal to 0 when x is equal to 1 or when x is equal to 7. If we substitute x is equal to 1, this goes to 0. So therefore the entire expression is equal to 0. And when x is equal to 7, then this parentheses is equal to 0. So therefore the entire expression is equal to 0. So we can say that the value of this x-intercept here is x is equal to 1. The value of this x-intercept here is x is equal to 7. And here we know that this entire curve lies above the x-axis. In other words, x squared minus 8x plus 7 is greater than 0 when x is greater than 7 or when x is less than 1. So we can say that the solution over here is that x is either greater than 7 or x is less than 1. What that means is for any value of x greater than 7, for any value of x greater than 7, for any value of x less than 1, this expression will be greater than 0. Next, what I want to do is I want to find the values of x for which the following quadratic expression is greater than or equal to 0. I want to find the values of x for which negative 2x squared plus 7x plus 15 is greater than or equal to 0. The simplest way to solve this would be to first rearrange this expression such that the coefficient of x squared is positive. So if I add 2x squared on both sides, I subtract 7x on both sides, and I subtract 15 on both sides, I get 2x squared minus 7x minus 15 is less than or equal to 0. We've essentially shifted everything from the left to the right hand side. Or we can say that if we multiply both sides by a negative number, in this case we're multiplying both sides by negative 1, we're simply going to switch the side of the inequality. So here I have the curve that has the equation y is equal to negative 2x squared minus 7x minus 15, and I want to find the values of x for which this curve lies on or below the x-axis. Those are the values of x for which this curve is less than or equal to 0. So again, we can solve for the values of x for which it's equal to 0. Those are the x-intercepts here. And then we can determine the values of x for which this expression is less than or equal to 0. If we take the product of the coefficient of the x squared term and the constant term, we get negative 30. That's 2 times negative 15. Now we get a negative product over here because the x squared term is positive, but the constant term is negative. So now we want to know what factors of 30 give us a difference of negative 7. Now we know that 10 times 3 is 30, and the difference between 10 and 3 is 7. So minus 7x can be split up into minus 10x plus 3x. So we can say 2x squared minus 10x plus 3x minus 15 is less than or equal to 0. We factor out 2x here, we get x minus 5 plus 3 times x minus 5. And this is less than or equal to 0. So what we get here is 2x plus 3 times x minus 5 is less than or equal to 0. So over here we know that when 2x plus 3 is equal to 0, x is equal to negative 3 over 2. So when x is equal to negative 3 over 2, this expression here is equal to 0. This 2x plus 3 is equal to 0, and therefore the entire expression is equal to 0. So this x-intercept here is negative 3 over 2. This x-intercept here is negative 3 over 2. We also know that this entire expression is equal to 0 when x is equal to 5. So we can say that this other x-intercept here is x is equal to 5. So over here we can say that minus 2x squared plus 7x plus 15 is greater than or equal to 0 when x is greater than or equal to negative 3 over 2 and less than or equal to 5. So we can say over here that when x is greater than or equal to negative 3 over 2 and less than or equal to 5, for any value of x in this range, the expression negative 2x squared plus 7x plus 15 is greater than or equal to 0. Or we can say that this curve 2x squared minus 7x minus 15 lies below the x-axis. So a simple way to remember this procedurally is that whenever we're solving a quadratic inequality, we want to ensure that the coefficient of x squared is greater than 0. Now, if we have an inequality that's greater than or equal to, then what we're going to have is we're going to have divergent values of x. In other words, the values in between 1 and 7 won't be included. For x is greater than 7 and x is less than 1, this inequality will be true because we have a greater than sign over here. And obviously, we're not going to include 1 and 7 since we don't have a greater than or equal to here. So we're not including the values of x for which it's equal to 0. Similarly, in this particular case, we were given an inequality where the coefficient of x squared was negative. Simply rearrange the expression so that the coefficient of x squared is now positive. And now what we have is we have an inequality where we have less than or equal to 0. Now, whenever you have a less than or equal to 0 over here, for whatever values this expression is equal to 0, the values in between will be the ones that satisfy the inequality. So in this particular case, x would have to be in between negative 3 over 2 and 5 for this entire expression to be less than or equal to 0. And of course, in this case, we have a less than or equal to here because we have to include the values of x for which it's equal to 0.